Hello, it's Piotr here, and in this video I would like to describe the Warden project that I have been working on for the last few months. So what is Warden? If you take a look at the project page description, you may notice that it's an open source and cross-platform tool which simplifies the monitoring task, and is built with the C# language on top of the latest version of the .NET framework, which means it supports both the regular .NET platform and the .NET Core. Before I jump into the code, let me just clarify a few basic concepts as they are really important to understand what's going on. The Warden itself represents an instance which oversees the whole monitoring logic. What you can do with the Warden, besides configuring it, is to start it, stop or pause it, plus you can give it some unique name if you need to. Warden may contain one or more watchers that are responsible for monitoring the specific resources. For example, there is a web watcher, performance watcher or MS SQL watcher, and each one of them deals with a different type of monitoring. By using the web watcher, you might either make a simple ping to check if a website is responding, or do more advanced stuff like making a POST request to the API and validating its response or headers. Same goes to the MS SQL watcher, where you could just try to open a database connection or even run a SQL query and ensure it returns the valid data. All of these watchers are configurable and can be easily added to the Warden instance that groups them and executes in a single cycle called the iteration. So, we have the Warden, watcher, and there is also one more thing called the integration. As the name states, it integrates with some external service in order to provide a quick access to its operations. For instance, you might want to send an email message right after there is a failure in the system, e.g. the database is not responding. Surely you can define your own business logic for that and pass this function to the particular callback configuration, but why not make it simpler? That's why you can make use the built-in integrations like the SendRead or the HTTP API that are configurable and provide an easy access to the methods that you really need. Oh, did I mention the callbacks? Well, in the Warden project I've named them the hooks. And actually there's a lot of the hooks, or callbacks if that's the name that you prefer to hear, which you can plug into. However, I'll explain some of them during the coding, as it will be much more clear to see them in action. And one last thing. The Warden is available as a NuGet package, as well as all of the watchers and integrations. They are listed as separate packages, which means that you are free to choose what would you like to use. To find out more about this project, please navigate to the getwarden.net website to read about this feature, and there's also a link to the GitHub page where you can browse the source code along with the examples and read the detailed wiki documentation. Alright then, let's not waste any more time and finally open the Visual Studio. I have already created a new project of the type console application and named it the monitor. The first thing I did was to install the Warden package using the package manager console and running the simple install-package warden command. Now let's do some actual coding. As you may have noticed, I have already prepared the simple configure warden method that actually creates an empty configuration of the warden and returns a new instance of the warden. Now let's try to run the application. Beware that it makes use of the async pattern, which is the reason why I'm using the task way all within the console application. Well, nothing happens since we didn't really configure anything useful yet. So let's try to set up a simple website monitoring. The first thing that we need to do is to install the web watcher. So let's run the NuGet package manager again. Okay, once it's been installed, we can add it to the Warden instance, for example, like this. And then just invoke the add watcher and pass our web watcher. Okay, that's the first way to do it. Now let's simplify this a little bit. Okay, looks better, but we can go even further and simplify it even more. Yes, you can make use of the available extensions and just call the addWebWatcher method in the Warden configuration directly. It's really up to you which one do you prefer, as they provide the same functionalities when it comes to internal configuration of the particular watcher. If we run the application now, still nothing happens. And why is that? Because even though the Warden executes the web watcher under the hood, you need to make use of the hooks, or callbacks if you prefer to name them this way, to actually intercept the underlying flow. Let's try to make a simple hook then. The hooks can be configured in multiple ways, depending on your needs. if you want to declare a hook that will be unique for the particular watcher, you need to make use of the available method overload while configuring this watcher. In this scenario, it will be just a lambda expression. As you may have noticed, there are many different types of hooks, such as onCompleted, onFailure, onSuccess, etc. and also their asynchronous versions. For this scenario, let's use the onCompleted, which accepts one or more expressions of type action that receives the iWarden check result type as the input parameter. So let me declare such function first. Now, we can pass it to the onCompleted hook configuration. Okay, seems they will all set. So this is where the things start to get more interesting. Now we are getting actually some data that can be used for further processing. Let's do something quite simple with the result, such as logging the output to the console window. So if we run the application now, voila! We are finally getting some useful information. In order to prove that the web watcher actually works, let me change the endpoint that is being monitored from 200 to 400 and run the application again. Now we can see that the result is not valid anymore due to the fact that the HTTP status code of 400 indicates the bad request. So it seems that our web watcher is actually working. So far so good. Let's try to extend our simple watcher to do something more useful, such as validating the API response. For the sake of this example, I will still use the HTTP stat US service, but you can trust me on that it works as it's expected to be. So let's add a new web watcher to the pipeline. We can actually give it a custom name, which is not required of course, but why not to do that? The second parameter would be the API URL, and the next one is the HTTP request type. So let's assume we are doing the POST request to the endpoint 200 and passing some data, and maybe even the additional request header such as the custom header. So how can we actually validate the response? Let's move further with the web watcher configuration, and now we can pass the lambda expression in order to make use of the configurator. It has quite a few options such as with timeout, where you can set the HTTP request timeout using the timespan value, or even provide your own implementation of the HTTP service that will execute the actual request by using the with HTTP service provider. Anyway, what's interesting for us right now is the ensureDead method, when we are getting the actual HTTP response and may validate its header, status code body. To keep it simple, let's check if the response contains any headers. But before we run the application, we need to use some hook to intercept the data flow. Surely we can define a unique hook for the API watcher, similarly to the web watcher, but unless you really need to do that, you can actually define a hook or set of hooks that will be common for all of the watchers by using the set global watcher hooks while configuring the Warden. Just take a look at this. So here is my common hook method, and here is the set global watcher hooks configuration. So if I run the application now, you can see that the common hook will be invoked twice and the unique webhook only once, which is of course correct. And again, to prove that the API watcher actually works, let me just change the ensureDead expression to verify that the response has no headers, which is of course false. If I run the application again, you can see that we are getting the failed validation, since the API actually includes the headers in its response, which states that our hooks, both the unique watcher hook and the common watcher hook, works just fine. And how we can differentiate between the watchers if we are using the common hooks? For example, by looking to the watcher name or type. Actually, if you take a closer look at the iWarden check result interface, you may notice that it contains some useful properties. What is nice about that is that each watcher has its own result type that has the additional interesting type of data. We may access this by casting the iWatcher check result included in the iWarden check result into the particular type, for example, the WebWatcher check result, which, as you can see, contains a rather useful stuff such as the request, response, or the request URI. Of course, in a typical scenario, you would probably want to check the watcher type or name first, or at least use the S operator while performing the cast operation, in order not to get a null result for a different type of watcher. Yet here, since we are using just a web watcher, it's totally fine. Alright, that's enough about the web watchers. Let's actually perform some other check. If you navigate to the project website, which is getwarden.net, or the project repository on GitHub, you may find additional watchers that can be used to perform the monitoring task. By clicking on the watcher name, you can read a detailed documentation about its configuration, the result type, and so on. So let me use this MS SQL watcher, as I would like to ensure that my database works just fine. I'll start with installing the MS SQL watcher package first, using the NuGet package manager. Okay, now I can add this watcher to the Warden by invoking the available add MS SQL watcher extension method. Just like this. Alright, here I can set the watcher name, but let's skip that and pass the required connection string to the database. Let's run the application now and see what happens. Oops, seems that we have an issue. Well, the thing is that the Warden is not fully cross-platform yet, as some of the watchers make use of the external libraries which do not support the .NET Core currently, and in that case it will be the Dapper. To fix this, we can just remove the DNX Core framework from the project.json file. Just beware of that fact, and hopefully one day all of the watchers will be truly cross-platform. For now, only WebWatcher and of course the Warden core supports the DNX core. If we run the application now, everything works just fine and the MS SQL returns the value result which is correct, as I have a running instance of the SQL Server database on my computer. You can extend the MS SQL check similarly to the API check, for example by running the SQL query and validating the response, but let's keep that for now, as I would like to present some other features of the Warden that you might find useful. The first one will be the hooks designed for the Warden itself, not the watchers. It's configurable by invoking the setHooks method, which also accepts the lambda expression. So let me just paste the prepared method and pass it to the onIteration completed hook. Okay, so let's run the application now and see what happens. We are getting quite a big amount of the information now. For example, the Warden name, number of the iteration, the list of the watchers that have performed the checks, their execution times, and some other useful stuff. I encourage you to play with the hooks on your own, as there is really a lot of them available, and you should be able to find the ones that will suit your needs. Before I finish this video, I would like to present another concept, which would be the integrations. Let's assume that you want to send an email message for the first time that some resource fails, and then another one when the resource goes back online. For that, you can use the SendGrid integration, so let me just install this one by using the NuGet package manager. Now, let's integrate the Warden with the SendGrid. It can be done in two ways, same like with the watchers, either by calling the generic addIntegration method and passing the configured instance of the selected integration, or by invoking the available extension method, which would be integrate with the SendGrid in that case. Here you can make use of some method overloads, pass your API keys or credentials, and configure integration. Again, pretty much the same like with the watchers, except that you can't really configure the hooks for integrations, as it wouldn't make much sense here. So let's just assume this is the valid API key and the email address of the sender. So how can we achieve our goal, which is sending an email when either the first failure or the first success check after the failure happens? Quite easily actually. You can either use the previously described watcher hooks, but have to bear in mind that in that case you would receive as many messages as many watchers have fulfilled the given scenario, or use the kind of so-called aggregated hooks, especially designed for such kind of situation. This is how it will actually look like. At first, I will invoke the setAggregatedWatcherHooks operation and make use of the available overload that accepts both the hooks and the integrations. Here, inside onFirstFailure async, I will pass the results collection and invoke the available SendGrid integration sendEmailAsync method by passing some useful information. And we can do exactly the same with the onFirstSuccessAsync hook. Well, almost the same, as it should probably be a good idea to change the actual message since the monitored resource just became available again. Remember that since you have the access to the Warden check result collection here, you can really dig into the details and, for example, find out which watcher returned the valid result and which not, etc. and compose a very detailed message or a system one. And eventually, we have come to an end, as this is all I have wanted to present to you in this video. Of course, there's many more topics and watchers that have not been discussed here, however my intention was to describe the most important concepts of the Warden and how you can quickly get it up and running. You can find the documentation on the project's GitHub page, as well as the examples available in the source code repository. I hope that you have enjoyed this video, and please stay tuned for the next one where I'll discuss the Warden web panel, which provides the user interface for the Warden library and can visualize what's really going on with your system monitoring. Thanks for watching and see you soon!